Okay, when it says consider the differential equation, again, that does not mean you use the Sassy method necessarily. They're just giving you the formula for the derivative. So what you should be thinking of is something like this. You don't have this formula, you do have this formula. You have a way of finding slopes on a curve. So there's some curve, we don't know what the curve looks like, so just pretend it's this, in the golden notes. And pretend this is our curve. I've got to do my calibration. And the formula dy dx is how we can find the slope at any point on the curve. So this finds slopes. Another way to think of it is, in other situations, what you could think of it is you have an amount. The amount is the equation y equal whatever, or f of x equal whatever. And then you have a rate. The rate is dy over dx. So that's all we know so far. It says let y equal f of x, so right here, be the particular solution to the given differential equation. This equation here. All that means is they're giving you this rate, and if you work backwards using the Sassy method, you can come up with an equation called y equal or f of x equal. Again, you have a curve. Don't know what the curve looks like. The equation for the curve, they're telling you, is going to be y equals something, or call the equation f of x equals something. Either way, it doesn't matter. But what you're doing is you're starting with dy dx. You're trying to work backwards to get this equation. So you're going to have to use the Sassy method to do that. However, be careful here. It says, so that's all they're describing. So they say, oh, there's this solution equation, we've got the differential equation with this initial condition, but nowhere in the problem does it say to find this yet. Instead it says write an equation for the line tangent to this thing at this point. So what we're really doing in part A, part B here, is there's a point here, the x-coordinate is 2, the y-coordinate is 3, it told us right here, and we want to create an equation for this line that happens to be tangent to that point. So this is, we've got to use the y equal. So this is yet another problem where you've got to keep track of the fact that you've got an equation for a line tangent that finds all the points on that tangent line. You've got an equation unknown at this juncture for finding all the points on the curve. And you do have an equation right now that can be used to find all the slopes on the curve. So I'm going to use that to find the slope on the curve right here. I want to find that slope. So I'm going to write down dy over dx at x equal 2 and y equal 3 is going to equal 3 squared, 2 minus 1, oh, that's pretty easy, that's just 9. You wouldn't have to simplify if you didn't want to. So now I know the equation of my line tangent is 9 parenthesis x minus 2 plus 3. I've written an equation for a line tangent to this graph they're talking about at x equal 2. By doing that, check the scoring guide. I have earned 1 point. By the way, they mentioned in the most recent information we received on Tuesday that you will not need to draw any pictures to get points on this AP test. So if you see me drawing pictures, that's just because it helps me understand and hopefully helps you understand. But for example, there won't be any slope field questions because that requires you to draw a picture. Use my equation to approximate f of 2.1. So now I say, well, that's like saying here's x equal 2.1. The y-coordinate on that brown curve would be whatever the value of f is at 2.1. However, we do not have a formula for f. So they want you instead to go find this y-coordinate here. So that y-coordinate is also, that x-coordinate is also 2.1. We're going to find the y-coordinate using this equation here. So we write f of 2.1. We're approximating this y value right there. Should make that green. We're approximating this y value right there. So f of 2.1 is approximately 9, 2.1 minus 2 plus 3. I don't need to go any further. Stop right there. That's one more point. So a total of 2 points on this problem.